Taking a look at this first problem, we're looking for an opposite match, and we see one on the y's. We've got a negative 6y and a positive 6y. So we can go straight to the next step of adding the two equations together. 8x equals 16. Now we can solve for x. We'll divide both sides by 8 to get x alone, and x is equal to 2. So if we're thinking about the ordered pair where the two lines meet, we know it's going to start with a 2, but we don't know what it ends with. So we need to take that 2 and substitute it in for x in one of the original equations. I'm going to choose this one because it doesn't have any negative signs. So when I do that, I have 3 times 2 plus 6y is equal to 48. 3 times 2 is 6, so 6 plus 6y equals 48. Subtracting 6 from each side, 6y is equal to 42. If we divide both sides by 6, we see that y equals 7 when x equals 2, and that's the intersection point for these two lines. In the next problem, we don't have an opposite match yet. And there's no obvious thing to do since the first two are positive and the second two are negative. So I'm just going to work with the first two. I've got a 12x and a 3x. If I go ahead and I multiply that bottom equation by a negative 4, then that bottom equation will become negative 12x plus 8y equals negative 20. And notice that gives me an opposite match with the first equation. I'm just going to bring that first equation down. 12x minus 8y equals 20. All right. I can see that I've got a negative 12x and a positive 12x. That's the opposite match that I was trying to create. So it's time to add the two equations together. Well, negative 12x plus 12x is 0. I don't really need to write that because I'm going to look at the y's. But then I notice that 8y plus negative 8y also equals 0. So I've got to write 0 because that's got to hold that side. Negative 20 plus 20 is also 0. So there's a lot of 0 going on in here. Now, in our what to watch notes, we saw what happened when we got something like 0 equals 19. Those were not actually equal to each other. But notice in this problem, 0 does equal 0. This is a true statement. So this absolutely can happen. In fact, it happens everywhere along the lines. So this has infinitely many solutions. These two lines are actually the same line, which is why they share all of their points. So there are infinitely many solutions along that line. Next, we see a word problem. This says we're supposed to write a system of equations and solve using elimination. Here's the word problem. Washing 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. How long does it take to wash each type of vehicle? So it sounds like we want C for the number of minutes to wash a car, and maybe T for the number of minutes to wash a truck. Because the question is, how long does it take to wash each type of vehicle? Well, if I'm going to wash 2 cars at C minutes per car, then 2 times C would be the number of minutes that we spend washing cars. To that, I have to add the amount of time it takes to wash 3 trucks. Well, 3 times the number of minutes it takes to wash a truck would be how much time I spend washing those 3 trucks. And we're told that altogether, that takes 130 minutes. So that lets me build up my first equation. Now my second equation is going to follow the same pattern. I have 2 times C for the amount of time it takes to wash 2 cars plus 5 times T for the amount of time it takes to wash 5 trucks. And we know that that equals 190 minutes. So now we can solve by elimination. I don't have an opposite match yet, but I do have a match. I've got a 2C and another 2C. So if I simply multiply this bottom equation by a negative, like a negative 1, that's going to give me my opposite match, and I can then add my 2 equations together. So 2C minus 2C is 0, which I don't need to write unless the t's also cancel out. I have 3t minus 5t, which is negative 2t. So I don't have to write the 0 because I've got the negative 2t to hold the place. 130 minus 190 is negative 60. So now I can solve for t. I'm going to divide both sides by a negative 2, and t is equal to 30. So now we know that it takes 30 minutes to wash a truck. But we also have to find out how long it takes to wash a car. So we're going to take that 30, and we can either plug it in for this t or that t. It doesn't matter. The numbers are a little bit smaller in the top, so I'm going to choose the top equation. So 2c plus 3 times 30 equals 130. Well, that's 2c plus 90 equals 130. And if we subtract 90 from both sides, 2c is equal to 40. If we divide both sides by 2, we'll find out that c is 20. So it takes 20 minutes to wash a car and 30 minutes to wash a truck. Notice in a word problem, I don't necessarily answer using an ordered pair like an x comma y. Instead, it makes sense to answer in words, right? If we ask the question in words, we probably want to answer the question in words. Next, we see another word problem. The band sells popcorn for $5 per can and mixed nuts for $8 per can. They sell a total of 240 cans and receive a total of $1,614. Find the number of cans of popcorn and of mixed nuts. Okay, so it sounds like our variables could be P equals the number of cans of popcorn and N equals the number of cans of mixed nuts. Now, P and N are just the variables that I chose. If you like X and Y, then you could have picked one to be X and one to be Y. If you like totally different variables, you could pick whatever totally different variables you like. Personally, I try to pick variables that help me remember what they stand for, which is why I picked P and N. All right, it says they sell a total of 240 cans. So the number of cans of popcorn plus the number of cans of mixed nuts must equal 240. That gives me a nice simple equation to start with. The second equation is a little bit more complicated because it's about money. So if I think about this, if I sell P cans of popcorn at $5 per can, 5P is the amount of money that they bring in from selling popcorn. Similarly, they bring in 8N or $8 times N cans in selling mixed nuts. And then we know the total for that. So the sum of those two things is 1,614. So we now have a system of equations written in standard form. We have to create an opposite match if we want to solve using elimination. So personally, I would just pick the variable with the smaller number. So in this case, P has a coefficient of 5, and we're going to multiply that top equation by negative 5, because remember, I'm not just going for a match, I'm going for an opposite match, so I need to use the opposite sign. So I'm going to rewrite that equation underneath. Negative 5P minus 5N equals, all right, let's look at this. I know I'm going to get a negative number. So 5 times 200 would be 1,000, and 5 times 40 would be 200. So that looks like 2,000. Sorry, I got to back up. 1,200 would be the amount of money that we're bringing in there. All right. So I can now say 5P minus 5P. Those cancel out. But 8N minus 5N don't cancel out. They leave me with a 3N. And 1,614 minus 1,200 is going to leave me with 414. To get the N alone, I want to divide both sides by 3 to find that N is equal to 138. Now, let's go back and see what did N equal. N was the number of cans of mixed nuts. So we can say they sold 138 cans of mixed nuts. But we also have to find out how many cans of popcorn. So I'm going to say, and but I'm not going to finish my sentence yet. Remember that nice simple equation, P plus N equals 240? We could take this 138 and substitute it for N in that nice simple equation. So we're going to say P plus 138 equals 240, and we're going to subtract 138 from each side. So P will be 102. So we can now finish the sentence. And 102 cans of popcorn. Again, we answered in words instead of in ordered pair because if the question is asked in words, we want to go ahead and answer in words.